Welcome back, everybody. We're here right now with Grace Jansen, developer advocate with IBM. Grace is in sunny, well, relatively sunny London, or England right now, getting ready to tell us all about thriving in the cloud, going beyond the 12 factors. Can't wait to hear about it. Grace, if you would.
Great. Thank you so much. So thank you for having me. It's great to be here. Great to join you all, even if it is from England and not with you in person, hopefully next time. But thank you for joining this virtual session where I'll be going into how we can really not just survive in the cloud, but really thrive in the cloud by going sort of beyond the 12 factors, implementing them and sort of iterating upon them to really make sure our apps are ready to thrive within that environment. I'm a developer advocate at IBM within the UK, just as my general background. And if I don't get around to any of your questions throughout this presentation, then please do feel free to tweet me, post something to me. My handle is there. It's at GraceJansen27. I'm active on Twitter, so feel free to head on over if you think of anything later. So first things first, why do we care about thriving in the cloud environment? You might have seen Toy Story and know this kind of picture. Ooh, the cloud, but in this case, the cloud. We get really excited about the cloud, and there's various different reasons why. The cloud offers us a bunch of amazing capabilities that we didn't necessarily have before when we were doing most things on premise. So what does the cloud offer? Well, it offers cost savings. The fact that they're able to do this at economies of scale means that these cloud providers should be able to pass on cost savings to you, and you should be able to save money by only utilizing the resources that you need rather than overspending, having all this resource that you're not necessarily using and having to pay for that all the time just in case you have a spike in load. So it should be cost saving. It also enables speed. So being able, and sort of scalability comes with that, being able to rapidly scale up and down the resources that you need depending on the load to your system, and being able to rapidly allocate those resources because again, that underlying infrastructure is there ready for you to use rather than you having to go off, buy your own server rack, have it transported and set that all up. So it's ready for you to go, which means having these resources is quite easy to scale and you can do it at speed. It offers resiliency. If one rack were to go down, you can fairly easily switch over to a different rack. You could also switch over to an entirely different data center if you want to. So it enables this increased resiliency in terms of how you're able to keep your application up and running no matter what happens to the underlying infrastructure. It also offers flexibility. So if you need a particular data center or you need to have your data stored within a particular country, for example, again, this can be offered within cloud infrastructure. Now, one thing you might not think about as an advantage of the cloud is the fact that it's sort of this fashion industry. You might not think of technology as, fashionable or a fashion industry, but actually when you think about it, it is. We follow these trends and these sort of like hype cycles of, oh, well, people are doing microservices. Maybe I should go and look at that. Or what about the cloud? Maybe I should go and look at that. In some respects, we are a fashion industry. We do follow fashion. And that's because often in our industry, the latest trends, for example, can offer great innovation. They're usually offering additional advantages or cool benefits, or they're exciting and they offer this increased innovation. And the cloud does exactly that. The cloud allows us to follow these fashionable trends to be able to offer this innovation to our end users, as well as utilize it ourselves. So these are all the various things that the cloud offers, and it explains why we're so excited about getting our applications onto the cloud. But what does it actually mean to be cloud native? Well, I took a look at a bunch of different definitions from various different vendors, and unsurprisingly, the one that sort of resonated most with me was from the CNCF. As the name suggests, they're sort of experts in all things cloud native. So their definition of what it really means to be cloud native is about utilizing technologies that empower organizations to build and run scalable applications in whatever environment you choose, whether that's a public, private, or hybrid cloud, being able to run it within a cloud infrastructure. So it mentions about various different technologies, and you might want to utilize things like containers, service meshes, maybe immutable infrastructure. There's various different technologies that exemplify this approach. But the nice thing about this definition is there isn't necessarily, it's not prescriptive in terms of the language you have to use or the platform or the technologies. It's just use technologies to empower you to run your application well in the cloud. And that's what I think cloud native is all about, running your application effectively within the cloud, no matter what platform you're on or what language you're using. When I put the other definitions, including this one, into like a word map, I then cut out all of the words that were specific to a particular platform, technologies, stacks, languages. And what I came back with is this word map. The bigger the word, the more often it came up in these definitions. So actually, this word map shows just general behaviors that are applicable to every application that are what it really means to be cloud native. To be cloud native, you want to be you want to have observability within there, scalability, resiliency, having that rapid aspect to it, robustness, having them being loosely coupled, not tightly coupled together within this distributed environment. And so these are the behaviors that we should be aiming towards to really enable our applications to thrive and not just survive. So how do we go about actually implementing these sort of very generic behaviors into our applications? And that's where I really like methodologies like the 12-factor app methodology. If you've not come across this before, it's a methodology that was originally defined by the developers over at Heroku for building cloud native applications. And you can visit, there's a website called 12factor.net that you can check out, and it goes through each of the factors within this methodology. As the name suggests, there are 12 factors involved in this methodology. And these are the factors. So we'll go through each of these in a bit more detail throughout this presentation, so bear with me with this. But essentially, this was an excellent introduction, this methodology, to the discipline of really building and deploying applications in the cloud and preparing teams for the rigor that's necessary to build things like production pipelines around elastically scaling applications. However, this was introduced some years ago, and since then, technology has advanced since the original creation of this methodology. And in some situations, it is necessary to really elaborate on these initial guidelines, as well as potentially add new guidelines that are designed to really meet modern standards for application development. And so by iterating upon this and looking at where technology and that underlying infrastructure has gone since the creation of these 12 factors, the origin of the 15-factor methodology was created. If you've not come across this one, it's essentially the 12 factors just iterated upon and 3 extras added on top. So this was created by a guy called Kevin Hoffman from Dynatrace, and he's got a book on it. So if you want to go and check it out, it's on O'Reilly, and the link is at the bottom of this slide. So as I said, it's loosely based around the 12 factors. We've just got some additional revisions to them, and then these 3 additional factors. So the 3 new ones are API first, telemetry, and authentication and authorization. So this is where we're starting to go beyond that original 12 factors. We're iterating upon that and adding additional needs based on what we've discovered since we've started putting applications onto the cloud, what we really need to be able to thrive in this environment. So let's take a closer look at how we can utilize each of these factors to be able to really enable our applications to be cloud native and to exemplify the behaviors that we saw in that word map. So this is when we're going to take a closer look. Now you'll notice at the bottom of each of these slides, I've actually put a color coordinated bar. If it's gray, that means it links to an original 12-factor application, 12-factor sort of factor from the methodology. If it's yellow, it means it's one of the new ones from the 15-factor that wasn't in the originals. So I'm trying to help you sort of link the 2 together and see how they've been revised and sort of iterated upon. So the first factor that we need to focus on to build cloud native applications is this factor, 1 code base, 1 application. So fairly similar to the original name, which was just code base, except this time we really are being specific in terms of the ratios we're dealing with when we're building our applications. So this factor is all about the fact that there should be a 1-to-1 relationship between your application and your code base, but a 1-to-many relationship between your code base and your deployments, as you can see from the diagram here. And really that's to enable proper versioning, is to enable sort of to support collaboration between the development and various other teams, and it enables faster time to market. They should also be stored in some sort of version control, so you can be able to roll back if you need to, and know the various different versions you're using within that application. So how do we achieve this factor? Well, actually, there's a bunch of open source tools available, and you're probably already using them. So you can use a Git repository. Now, as I said, lots of open source ones available like GitHub, GitLab. You might be using GitHub Enterprise or one of the alternatives. There are some that are specific to cloud providers that you might be using, like Google Cloud Source Repositories or AWS Code Commit. And there's also others like Bitbucket, SourceForge, and Launchpad. So we can utilize these Git repositories to be able to have that single code base for our applications and to be able to use that for the multiple deployments we need. Now, the next one, factor 2 in this 15-factor methodology, is API first. This is one of the new factors that was introduced. So it's worth bearing in mind when I'm going through these that some of these factors don't necessarily directly map to specific physical requirements that are imposed by the cloud. Some of them are more to do with habits and behaviors of the people and the organizations building these applications and enabling them to build in a way and have processes in place that enable to build these applications to be cloud native. So what is this one all about? This is all about really giving teams the ability to work against each other's public contracts without having to interfere with the internal development processes. So it's really about API first means that what you're building is an API to then be consumed by client applications and services. Why do we bother with this one? Why was there a need to add this? Well, it really helps to avoid things like integration failures and to formally recognize your API as a first-class artifact in that development process. This also enables greater collaboration with stakeholders. So by really having this API first approach, it means that you can test or vet the direction and plans that you're doing in terms of what you're going to be exposing for others to be able to utilize before you invest way too much time in supporting an API that nobody wants. So it enables you to test them, to make sure that you're really meeting the needs of your stakeholders, whether that's other internal services or external services or clients, and gives you this ability to test that before you put too much into it. And it enables greater flexibility because if you discover that it's not what they want, you can fairly easily change that without having lost too much time and resources. So how do we go about actually enabling this factor? Well, again, there are some open source tools that you can utilize. So the first thing you need to really implement before you start looking at tools is you need to have this mindset that you are all participants in this ecosystem and that you need to share public contracts to be able to be this effective participant. You can utilize things like OpenAPI or API Blueprint, which are open source specifications. And you can also utilize tools that then implement these open source specifications like MicroProfile OpenAPI. Or there are alternative proprietary products if you already have, say, contracts with these proprietary offerings like Apiary or IBM's API Connect tools. The OpenAPI initiative, or OAI as it's often called, is focused on really creating and evolving and promoting a vendor-neutral description format. So it was originally based around the Swagger specification, and you can make use of it to have that sort of neutral description format that you can utilize across various platforms and vendors and share with others to be able to create this sort of common language that you can all use when it comes to your APIs. So it can be really useful for that. So this is a fantastic new addition, really taking that step towards recognizing that we're all participants in this ecosystem and that we all need to have APIs to be able to consume each other's services and have that bounding. So to bind our own service without having a need to interfere with the source code in any other service in this infrastructure. Number 3, dependency management. Again, this is probably familiar to you. This is related to the original dependencies, so not that much of a change. This factor is all about explicitly declaring and isolating your application dependencies. So in a classic enterprise environment, we're very used to this concept of, say, mummy servers. So this is a server that provides everything that our application needs and literally takes care of their every desire, from satisfying the application dependencies to providing a server in which to host the app. The cloud, however, is a maturation of that classic enterprise model. And as such, our applications have to grow up. They need to grow up to be able to take advantage of the cloud. They can't be reliant on this mummy server anymore. And so they need to be able to bring their own dependencies with them because they can't rely on that being available in every cloud environment they're being deployed into. And so to be able to do this, we can use things like declaration manifests that are stored within the code base, and use things like dependency isolation tools during application execution. So why does this matter? Well, it helps to provide consistency between our various environments. So whether that's development, testing, production, it means we can utilize the same dependencies in all of them. It also simplifies our setup. So if a developer is new to your application, it helps to simplify the dependencies that they need on their machine to get started utilizing your application. It helps to support portability and flexibility, one of those characteristics of cloud native applications. Your app might need to move, say, cloud platform, or it might need to use different versions of a particular dependency. And so having this ability to isolate and declare them explicitly enables us to have portability between cloud platforms, and it enables greater developer productivity. So how do we do this? Well, the first step is actually one that you need to take, which is to basically go through your application and explicitly declare and isolate the dependencies that you're using. You can use things like Maven and Gradle to be able to do that, and they are really useful tools for this. So if you're using Maven, you'll be using a pom.xml file to basically declare all your dependencies. If you're using Gradle, you'll be using a settings.gradle file. It's up to you which you choose. There are some big opinions within the industry as to which is better. That's your choice. Either way, they are some really helpful tools to help with this. And again, this also enables you to freely move up and down versions without having to go all the way through your code and find every dependency in every class, etc. So really useful, especially in our cloud environment. Number 4, design, build, release, and run. Now you'll notice the only difference here is actually the addition of that design step. So we already had build, release, run in the original 12 factors. And this factor is essentially all about explicitly separating out the various different stages of building an application. So there was a need to introduce this design stage on top of the build, release, run, because previously when we maybe first started going into cloud, design wasn't really thought of necessarily as a separate step that we need to do within this process. But actually, and when we were doing more waterfall style development, we generally tend to design the entire thing end to end right at the very start. And there wasn't that much wiggle room as we went through the development process. But now we're in a more agile world. We need to be able to be agile in terms of changing the design if we need to as we go through this development cycle. So with this design stage, we essentially design small features that then get released. But we also have a high level design that's then used to inform everything we do. But we have to keep in mind that that high level design might change, and that small amounts of design have to be a part of every iteration rather than just entirely being done up front. So it's during this design phase that, say, arrangements are made to declare dependencies, as well as the means by which those dependencies are going to be vended or bundled within the application, looking at the APIs that we're producing. And so it's a really important step, again, to make sure that we're meeting the needs of our stakeholders, and that we're not wasting time going through this entire cycle and finding out that something we maybe designed right at the start isn't quite right. And so it's an important addition, adding in this design phase. But this factor is important overall because it helps to effectively make our release management much more effective. It helps to enable maximum delivery speed whilst also still keeping a high confidence through things like our automated testing and our deployment cycle. So how do we achieve this? Well, this is, again, more of a methodology or practices sort of thing, more for the people in the organizations rather than specific technologies. However, you might consider using things like a CI/CD pipeline, and there are tools like Tekton that you might want to use for that. So that's number 4. Number 5, this is configuration, credentials, and code. So in this one, it relates to the original 3rd factor. And this is all about essentially, again, ensuring that there's strict separation between the code and your configuration. Now, credentials was specifically picked up in this edited version of this factor because arguably credentials are some of the most sensitive information you could possibly have to do with an application, and they have absolutely no business place being in a code base. And so it should be obvious as to why we don't want to be including credentials directly within our code base. When it comes to configuration in general, it does include credentials, but configuration is a more broader term, and it can include things like URLs or other information about backing services, information necessary to locate and connect to databases, information that might normally be bundled in properties files or configuration files. So all of this we want to be able to separate out from our code. Why do we care about this? Well, it enables us to modify our application behavior without actually making specific code changes. So we can just go in and change those configuration files. It also simplifies our deployment to multiple environments. It helps to reduce the risk of leaking credentials and passwords, which is a huge security risk in many applications. And so we really need to be making sure that that is a step that we're thinking about. Do I have any credentials stored within my code base? And it enables more effective release management. How do we do this? First steps on you. You need to be extracting all application configuration to environment variables. Now, there are tools and technologies that can help you with this. So, for example, MicroProfile offers an API called Configuration, and that enables you to place configuration in properties files that can then be very easily updated without having to recompile your microservices. You can also make use of things like CDI, so using CDI injection to directly inject a set of properties. I realize I've talked about MicroProfile and haven't really delved into what it is. If you've not come across MicroProfile, you should definitely check it out. It's a really cool community-driven specification that really helps Java and Jakarta EE applications and gives them APIs and components necessary when you're designing microservice-based or cloud-based applications. So definitely check out that specification. Lots of different vendor implementations available for it as well. So that's number 5. Number 6, logs, is exactly the same as the original logs. So this is important, but there hasn't really been much iteration on this in the 15-factor app methodology. It's fairly similar. It basically just says, treat your logs as event streams and only log to stood out and stood please. So truly, a truly cloud-native application should never really concern itself with routing or storage of its output stream. This factor is really about making logging a platform concern, not a developer concern. So this gives you improved flexibility for introspecting behavior over time and enables things like real-time metrics to be able to be collected and analyzed. How do you do this? First step is log to stood out and stood only, please. So fairly easy first step. Treat your logs as event streams, and you might want to consider the aggregation, processing, and storage of logs as a non-functional requirement that should be satisfied not by your application, but by your cloud provider or some other toolkit. You might use tool suites like, for example, at the Elk stack. You can see at the top here, it's made up of Elasticsearch, Logstash, and Kibana. You might want to make use of things like FluentD, Splunk, Sumo Logic. There are a huge number of tools that can help you to capture and analyze your log emissions. So that's number 6, and there are lots of tools out there to help you with that. Number 7, bit of an abstract image here. I will explain it in a minute. So this factor, again, relates to the original factor, disposability, pretty much the same thing, not that much iteration. This factor is all about really maximizing robustness via fast startup and graceful shutdown. So this is where the image comes in. We should be treating our apps as cattle and not pets. Cattle generally get assigned numbers. If they fall ill, we tend to just replace them. And there's not as much of an emotional attachment to each individual within that herd as there is with pets. When it comes to pets, we give them individual names like Carl the cat. We love them. We help them get better when they're ill. We look after them. We don't replace them when they get ill. We nurse them back to health. And actually, this is not what we want in a cloud native application. If our microservice isn't healthy, we need to be able to gracefully shut that down and restart another instance of it. So we need to be treating our applications more like cattle. They have to be disposable. They need to be resilient to unexpected and sudden shutdowns. Why is this important? Well, this really enables fast and elastic scaling. It enables increased resiliency. It allows us to have rapid deployments of, say, new code or config changes, and provides robustness and auto-scaling. How do we go about doing this? Well, first thing is to minimize any work that you're doing on startup. So don't depend on things like shutdown hooks, and maximize robustness with fast startup and automatic scaling. You can utilize things like fault tolerance. So again, this is a MicroProfile API. So fault tolerance can help you to basically put in behavioral characteristics or responses in case anything was to go wrong with your microservices. So say if it goes into bad health or isn't responding, to shut it down, you can implement all that fault tolerant behavior using that API. So that's number 7. Number 8 is backing services. Again, just like the original backing services. So this factor, I'm going to whiz through it quickly because it's fairly similar, is just about treating backing services as bounded or attached resources. So there should be no distinction between local and third-party services, and all of your resources should be attached via URLs that are stored in your application's config somewhere. Why does this factor matter? Well, it's about really enabling that loose coupling and not having dependencies upon particular microservices and having that sort of tight coupling that we don't want within distributed systems. So it enables us to have that loose coupling between your service and your deployment. No code changes are then required if you want to update your backing service. It allows operators, if you're using those, to be able to swap services out as they see fit. And it enables increased resiliency and agility. So the possibility to attach and detach bound resources at will whenever you need them. How do you do this factor? Well, it's fairly simple. Just treat backing services as attached resources. And again, you can utilize things like microprofile config to be able to help with this by having that externalized configuration, stating the particular URLs where you're connecting to those backing services instead of having it directly within your code. Number 9, environmental parity. So there's been a slight addition to this one. It was originally the dev prod parity, which basically just specified development or production. Whereas in this one, we basically widened that to say all environments. So essentially it includes production, staging, QA, DevSecOps, developer, whatever deployments you use, whatever environments you use, you should have parity between them all. So this is all about applying rigor and discipline to your environments to make sure that you and your entire organization have the confidence that your application is going to work wherever it gets deployed, no matter what environment. So it's all about making sure that you utilize really the same dependencies, the same backing services, the same configuration. So ensuring that they're as similar as possible. So you really mitigate the risks of potentially coming up against unexpected failures when you get all the way to production, for example. Why is this? Well, as I said, it lowers that risk of unexpected failures. It supports continuous deployment and it enables greater reliability, which is really important when we're often switching between different environments when we're in our pipeline. How do we do this? Well, as I said, ensure you've got the same backing services used for all your deployments. Ensure you've got a solid continuous integration pipeline. And if you can, deploy to production as often as you can, because that way you are able to test in that proper production environment. You can use things like automated CI/CD pipelines to help with this, but also just general tools like container tools. So things like Docker can help to make almost production-like environments more accessible to developer workstations. So if you're trying to test your application in an environment as close to production as possible, you can use things like test containers or microshed testing. So they basically utilize containers on your local machine to be able to bring up things like backing services that your application might rely on and run integration tests against them all. So if you're interested in that, I've put a link to a guide that you can take part in. There's several throughout this presentation. It gives you hands-on experience with this technology. So that's number 9. Number 10 is administrative processes. Again, I'll just run through this quickly because it's exactly the same as before. This is just about running admin or management tasks as one-off processes. So storing code for admin tasks within the app's code base. This is all about safely debugging admin of production applications and enables greater reliability. Things like Kubernetes tasks can be used for this, or you might alternatively make use of Lambdas. 11, again, very similar. So this is port binding. So this is essentially enabling ops efficiency. So the principle of port binding asserts that a service or an application is identifiable to the network by a port number and not a domain name. So your cloud provider, again, this is about not within your application, but within your cloud provider, should be managing the port assignment for you, because it's also likely managing things like routing, scaling, availability, and fault tolerance, all of which require it to manage certain aspects of the network, including routing host names to ports. So really, this is about an application developed with exported port binding in mind should support this environment-specific port binding without having to change any code. So it enables ops efficiency. And how do we do this? Well, we export services via port binding. Again, you can utilize things like microprofile config to help with this. And you can also utilize things like Kubernetes config maps. Number 12 is stateless processes. So this is a slight iteration on the original, which was just relating to processes. Similar concept though. This is about executing your app as one or more stateless processes. So all of your stateful data should be stored in backing services of some kind. Any long-lasting state that you need should be external to the application, provided by those backing services. So in this concept, it isn't that state can't exist, it's just that it shouldn't be maintained within your application. Why is this important? Well, it helps to reduce deployment complexity. It allows for much simpler scaling and enables cloud compatibility. How do you go about doing this? Well, first things first, don't store any stateful data. Store all your stateful data in backing services. Don't use things like sticky sessions or your local file system. Don't use things like in-memory cache, please. Storing in a memory cache that your application thinks is always available can end up bloating your application and making each of your instances take up far more RAM than is really necessary. So in this one, you can utilize things like, again, microprofile can come in useful for this. You can use things like third-party caching products. So there are things like Gemfire, or Geode is the open source version, Jcache, Redis. All of them are designed to act as a backing service cache for your applications. So there's lots of open source tools available for you to utilize to enable this sort of stateless application. Concurrency, again, very similar to the original. This is all about scaling out via the process model and really treating processes as first-class citizens. So there was a time when if any application reached the limit of its capacity, the solution was just to increase its size. And an application could only handle some number of requests. Essentially, you just made the application bigger. You just add CPUs, RAM, and other resources to a single huge monolithic application. Essentially, you were vertically scaling. This is sort of typically frowned upon within society nowadays. What we more suggest is the more modern approach of horizontal scaling. So this is ideal for elastic scalability in which the cloud really supports. So rather than making a single big process even larger, you essentially create multiple processes and then you distribute that load of your application among these processes. So essentially, your microservices should be able to be scaled up or down depending on your workload. So scaling out horizontally, not vertically. Why is this important? It allows for very easy horizontal scaling and it enables us to auto scale as well. The first thing you need to do for this is split your app into separate runnable processes and be able to scale those independently. You can use tools like Kubernetes Autoscaler to be able to help you with this. 14, so this is one of the new ones. This is another new one here. Now you might be thinking, oh, but you covered logs earlier. Why are we doing telemetry now? Okay, logging is a great start, but it's generally a tool that you're using during development so you can diagnose errors and code flows. Logging is typically orientated around the internal structure of your app rather than reflecting real-world customer usage. So really, telemetry is about how you collect data once the app is released into the wild. So the concept of telemetry wasn't in the original 12 factors, but has been added. It's about the fact that, when you're building applications on your workstation, it affords you luxuries that you don't necessarily have when you're running in the cloud. You could have previously inspected the inside of your application. You might have executed a debugger and performed hundreds of other tasks that gave you deep visibility into your app and behavior. We don't have this kind of direct access when we have cloud-based applications. And so this is where it's really important for us to introduce monitoring of our application to be able to understand how our application is behaving and if it's doing what it was supposed to. And if not, why? So when it comes to monitoring, there are generally a few different categories of data. So you might be looking at things like application performance monitoring, domain-specific telemetry, or health and system logs. So why is this factor important? Well, modern applications are becoming more and more complex, and they're in this highly dynamic distributed environment. So it's really important that we keep up our logging and our metrics and our telemetry so we understand what's going on with them and make sure they're behaving as they should. How do we achieve this? Well, we can utilize things again like microprofile. So there are some APIs within microprofile like health and metrics, which enable you to utilize these APIs to, again, check the individual health of your microservices and the overall health of your application. It also enables you to gather metrics on them as well. So check out these guides if you're interested in trying those out. Last one, I promise, this is the 15th factor. Again, another new one. So previously, there was not really any discussion of security or authentication and authorization in the original 12 factors. As we all know, with news stories of applications being hacked, security vulnerabilities, security is a vital part of any application and cloud environment. So security should never be an afterthought, hence why it's been added in as this additional factor. So a cloud native application has to be a secure application. Your code, whether it's compiled or raw, is transported across loads of different data centers. It might be executed within multiple containers and accessed by countless clients, some of them legitimate, some of them nefarious. So really, it's about ensuring that you have the security within your application. You might utilize things like RBAC for that. If you've not come across RBAC before, it's role-based access control, and enables you to basically check that someone's role that's assigned to them enables them to access, whether they basically have permission to access your application. So what is this factor about? Adding additional security to applications through the use of authentication and authorization of users. It enables increased security, and we can use things like RBAC. You might want to utilize tools to help you with this. So you can use things like OAuth 2 or OpenID Connect, Keycloak. There are a bunch of others. You can also make use of things like JWT, which is JSON Web Tokens. Again, another API offered by MicroProfile, and that enables you to authenticate, authorize, and verify users. So again, lots of open source tools available to you. So what do these 15 factors have to do? Like, where do they all fit, and how do they enable those behaviors that I talked about right at the beginning of this presentation about being cloud native? Here is a generic mapping of an application pipeline, building it and then deploying it within a cloud environment. If we sort of put on top of that, map on top those 15 factors, and then map on top of that the behaviors that they enable, you can start to see where these factors come in terms of the development process and how they can enable those from that word map, those behaviors that really mean our application is able to thrive within the cloud. And so by following these 15 factors, you should be able to enable these behaviors and make sure your application's ready to thrive in the cloud. And as I said, you can use any of the tools that I mentioned throughout this presentation. If you want hands-on experience, I've put a bunch of links throughout the presentation, but there's also our interactive cloud native labs environment. This is a free online environment we created as like a sandbox for you to play around with. So head on over to that link if you want to try out any of our labs. They're all based on our Open Liberty guides. So if you want to check those out, head to the Open Liberty website. Again, all of this is open source. So if you want to contribute your own guide, feel free. It's all on GitHub. Otherwise, check them out on the website. So hopefully, as a quick summary, what I've shown you is that the 12-factor applications is a great start. But in order to actually thrive within the cloud, we have to look beyond it. And there are no excuses, I'm sorry to say. There are tons of open source tools and technologies that are available to help you on this journey. So as an action for you guys to take away, evaluate your own applications against these 15 factors and consider what you could do to really enable you to thrive within the cloud. Could you change any of them? Are you maybe not addressing some of them? How could you utilize these factors to improve your application? As if I haven't given you enough homework already, there are more links. If you are a keen bean like me and want even more links on any of these, check out this slide and the next slide. The slides will be available afterwards, so don't feel like you have to rush and grab them now. And you can check them out for additional information on some of those factors. Thanks very much for listening. I hope you've enjoyed it. It's been a pleasure joining you today.
Thank you so much, Grace.
Thanks.
I'm going to check to see if we got any questions while I wait to see if we get any questions pop up in the chat. I had one myself as per usual. You know, one of the nicest things I saw about all that, Grace, you know, when you have all of these 15 factors, you know, so much about what you're talking about is really taking advantage of, you know, cloud native, being able to use cloud. Is it, my experience has been, and I don't know if you found this as well, is that by doing all this stuff, you actually end up saving yourself some time and money by investing in all this? Because I mean, can you speak a little? I think a lot of people, when they see cloud, they think expensive, but I think some of that's because they're porting bad applications over and it ends up costing them much. Has that been your experience when using these 15 factors? It helps you save some cash by doing it?
Yeah, absolutely. I think, as going right back to the very start, as I mentioned, you should be utilizing cloud to have cost savings. It shouldn't be costing you loads more. That's just completely unintuitive of using the cloud. Really, things like utilizing that scalability, that was one of the main behaviors within cloud. It's not just about scaling up, it's also about scaling down again. The fact that you should be able to scale down your resources if you've got a very low load, for example, on your system, and that in turn should be saving you money. Being able to utilize things like automation, for example, should be able to save you money. A lot of these factors are about developer productivity, as well as actually ensuring that your application's working well in itself. And by enabling your developers to be more productive, again, that should be saving you time and money, because they should be able to go and work on some cool new feature, enabling you to sell to more clients. So really, it's about enabling cost reduction, developer productivity, and your application to be more resilient, reliable, and just provide a better experience. So I definitely think these factors have helped me with that. And I think I know a lot of people who have been helped by that. And so, yeah, if you're not saving money on the cloud, go back to the 15 factors and check.
I would agree, especially the developer productivity. The logging stuff speaks to my soul as trying to figure out when people don't get the telemetry and logging correctly in their cloud apps. Well, Grace, I haven't seen any questions pop up, but thank you so much. I learned a ton. It was great. And she's got her Twitter handle. Of course, we'll hop into the QA room afterwards. Thanks so much, Grace.
Absolutely. Thank you. Bye.